name's Chantelle, and within this presentation, we'll be thinking about an evidence-based approach for applying circular economy principles to healthcare products. And we'll be thinking about this in the context of the surgical operating theatre. And this is a good case example for us. We know that surgery is a really resource-intensive area, and in fact, it's responsible for around 27% of our NHS spend in England. And we can equate that to about 4.4 million tonnes of carbon dioxide equivalents each and every single year. And the surgical subspecialties with the greatest contributions, as you might expect, are trauma and orthopaedics, general surgery, and obstetrics and gynecology. Now, within the theatre itself, the main sources of greenhouse gas emissions are single-use items. You can see on the right-hand side there an image taken from an adenotonsillectomy. And here we found over 100 pieces of single-use plastic in that one operation. Anesthetic gases are really potent greenhouse gases in and of themselves. And we also have a major contribution from our energy consumption from the maintenance of the operating theatre, mainly relating to the heating, ventilation, and air conditioning. So when we look at the 5 most common operations, it won't come as a surprise that the knee arthroplasty has got the largest carbon footprint. But what's more interesting perhaps is the breakdown in terms of the contribution of the underpinning processes. And the area with greatest contribution is the production of our single-use items in red on the bar graphs. And that's the red at the bottom. There's a further additional contribution from the packaging of those single-use items in red towards the top. The second biggest contributor being our decontamination of our reusable instruments, and that's then followed by waste in yellow. So those are our 3 major contributors of greenhouse gases relating to the products that we use for the provision of surgery. And if we break this down further to think about the products themselves that are contributing here, what we see is that actually there are relatively few products that are responsible for the majority of the emissions. And in fact, it's 23% of products responsible for about 80% of the carbon footprint. And for those of you familiar with the Pareto principle, you'll recognize this as aligning with the 80-20 rule. And really, when we're thinking about driving action, we need to be identifying and targeting those products that have the highest impacts. And oftentimes these are single-use, often quite bulky plastic items. So that's really the problem space and the problems associated with surgery and our environmental impact. But the rest of this session will be really thinking about those mitigation strategies and what we can actually do in the real world to bring down our emissions. And a framework that we can use to think about these is the circular economy principles. And we're traditionally operating on a linear model where we extract resources, we use them once, and we dispose of them. And the circular economy really challenges us to try to maximize our energy and our material flows throughout our whole processes associated with everything that we do. And we can think about this in terms of principles that you'll be familiar with, so reduce, reuse, recycle, as well as a few others, such as repair and remanufacture. And we'll be thinking about those now in relation to surgical products and how they might be applied. And first and foremost, when we're thinking about making reductions in terms of our environmental impact within healthcare, we need to be considering those opportunities for reductions. We're going to have a much greater impact by reducing the need to use something altogether, rather than actually whether we use product A versus product B. And we can apply that across whole patient pathways and use lean management techniques to look for those opportunities to streamline patient pathways. And there are also plenty of opportunities when it comes to our single-use items. And we have a bit of a culture within healthcare of opening things just in case, but just opening things at the point of use when we're sure we really need them, that can go a long way. The other key area is looking at our pre-prepared single-use sets. And oftentimes these have items that are not routinely used by anyone within a given healthcare setting. And so we need to be liaising with industry to ask that these items are removed. And if we look at the handset that you can see on the screen there, None of the surgeons in my local trust use the white sponges. Those could easily be removed. And further, there are a number of items there which could be easily made reusable, including the kidney dish, the galley pot, the hand drape, as well as the light handle. And when we think about that evidence in terms of our single-use versus reusable items, our best form of evidence is something called a life cycle assessment, where we look at all of the environmental impacts from the raw material extraction through the manufacturing process, the distribution, the use phase. So for reusables, that will include the linen laundering or the instrument decontamination, all the way through to the waste disposal. And we have a growing body of evidence in this field and within healthcare. And systematic reviews indicate that we can see a reduction of 38 to 50% on average through switching from single-use to reusable items. And you'll see on the right-hand side there a graphic from my paper in Lancet Planetary Health. And on the right-hand side in the red, you can see all of the higher impacts associated with single-use items, and in blue on the left-hand side, the reusables. And you can see across a whole array of different healthcare products and an array of geographical contexts that we have reductions associated with the reusable options. And there are exceptions, and it's important that we understand why. And typically those studies that find that single use have got a lower environmental impact relative to the reusables have been undertaken in Australia. And here they use a much higher proportion of coal within their energy supplies, and that then translates into the energy that's used for the reprocessing, so the decontamination. And where those studies actually remodel the findings based on European or US energy grids, for example, then the reverse becomes true and the reusables are again preferable. And there are also a number of studies with some slightly questionable methodological assumptions that are made. I provide an example on the slide here where we see an author group comparing a huge number of reusable instruments to a very small number of single-use items. The clinical comparability is perhaps questionable, but in fact, if we could challenge industry to manufacture that heavily consolidated set into being reusable, we'd again likely see that the reusables were preferable. And sometimes it's not possible to opt for a fully reusable item for a number of reasons, but rather than switching to a fully single-use alternative, then there are options sometimes for using hybrid items that are predominantly reusable with a small single-use component. In my own analysis of laparoscopic cholecystectomy, I found that 20% of the emissions relating to products related to just 3 items. And these were the single-use ports, scissors, as well as the clipper pliers. And there were hybrid versions available on the market. And I modelled that this could reduce the carbon footprint by 75%. And if we were to scale this across all laparoscopic cholecystectomies undertaken in England, then we would save the equivalent of me driving over 1 million miles in an average petrol car each and every single year. And it's always really helpful when we do these sorts of analyses to look at the full life cycle costings. And we often see that environmental savings are associated with financial savings, in this instance to the tune of £11 million per year. And so if we're making reductions and we're using reusables wherever possible, the next biggest hotspot then is the decontamination process. And I evaluated how we might be able to optimize that, because that then becomes the hotspot. And I found that we could reduce this by around a third through a combination of strategies. It's really important how we actually prepare our surgical sets, and that we prepare these as sets as opposed to supplementary items. When we have individually wrapped items, these are all often double wrapped in single-use flexible peel pouches, and the way in which we actually load our decontamination machines is often much less efficient when we have the individually wrapped items when compared with the trays. And there's more that we can also do to make sure that we're optimizing the loading of our decontamination machines, as well as those principles that you'll be familiar with in other contexts in terms of using renewable energy supplies, as well as recycling as applied to our sterile barrier systems. And if we are using reusables, we're optimizing our decontamination. We can then think about how we might be able to extend the lifespan of our items further. And there are plenty of opportunities to repair our items. For example, I evaluated surgical scissors. These are the most commonly repaired surgical item, and found that we could reduce the carbon footprint by 20%. And there were cost savings in addition of around a third associated with repairing these surgical scissors when they become blunt, as opposed to purchasing new reusable equivalents. I also looked at what happened when we repair these items on-site versus off-site, and the major difference there is in relation to the turnaround times. And if we're really stuck with single-use items, then there are potential to, If we're really stuck with single-use items, there is potential to extend their lifespan through remanufacture and reprocessing, where these items are reverse engineered and they are essentially remanufactured for a further single use. And again, we have evidence from life cycle assessment to evaluate the impact of that. And we see, for example, on the right-hand side for an electrophysiology catheter, that we have around 50% reductions associated with using remanufactured items. However, that study assumed that there was the use of a heavy goods vehicle between the hospital site and the remanufacturing site based on a process going on in Germany. But where I remodeled that based on air freight from London to Germany, actually that gap rapidly closes and actually they become very much more comparable. So if we're using these services, it's really important that we avoid air freight, and that actually applies throughout our healthcare supply chain. And the final thing that we think about is optimizing our healthcare waste streams. And my own analysis found that there was a 50-fold impact difference between sending our waste for recycling versus high temperature incineration. The main benefit that we're going to see from recycling in the healthcare industry is where we start to see an increase in the recycled content of the products themselves. So often when we think about recycling, we're actually downcycling and we're using the healthcare materials in other industries, such as in construction or in agriculture. And finally, we can think about what happens when we combine these strategies together and we stack them all up. And when I applied this to the 5 common operations, I found that actually we could reduce the carbon footprint of those 5 operations by around a third. And during the pandemic, I also undertook a life cycle assessment looking at the environmental impact of the PPE that we used during the first 6 months. And I found that equated to over 100,000 tons of carbon dioxide equivalents. That would be the same as me flying from London to New York over 244 times. And it was possible to reduce the carbon footprint by 75%. Through a combination of strategies there, including domestic manufacture, mainly because we use a higher proportion of renewable energy sources in the UK as opposed to where these things are typically manufactured, such as China, Malaysia, Mexico. And there were further opportunities for rationalising our glove use, as well as reuse of our gowns and recycling too.